This is the column layout of the building for which we are going to design the structural design. Okay, these are the total axial load on the respective columns. This we have arrived in the previous video. The column moment will be there only in the columns remaining in the exterior of the building. These columns 1, 2, 3, 4, 5, 6, these columns will have bending moment in the column, as well these columns, as well these columns. And this column will also have the bending moment because there is no beam in this side. So this is 3 beam junction. This will have bending moment. This column will also have some bending moment. Okay. This calculating the bending moment in the column is done mainly by moment distribution method. This cantilever method is generally used for the horizontal load caused due to wind force. So this we shall take in some other video which will come very late. Now we should do the design based on moment distribution method only. But describing this moment distribution method will be a laborious thing and involving major calculations. So in going into that will become uh, will not be so easy. So we shall have a rough idea to calculate the bending moment in the column. Before that, I will give a short introduction about this moment distribution method. This is the row number 1 or frame number, sorry, row number 5 may be called as frame number 5. For this portion, this column, this column, this column and this beam, we shall analyze early depth. That is, we shall see that introduction about this frame only. This is the cross section of the total building. These are foundations, ground floor, first floor, second floor, third floor, or this is fourth floor or roof slab. Here we are going to design the ground floor roof slab or first floor slab. To design, make a calculation for the frame noted within this yellow line. This is first column, central column, last column. This junction point of first column and the beam is called as A, then B, C. This column is called as B, this column junction is called as C. The lower part is A1, higher part is A2, the lower B1, higher B2. These things I have named in. This is the layout of the building. This green line indicates the UDL, uniformly distributed load on the beam. This uniformly distributed load is required for calculation for finding the bending moment in the respective columns. Now we shall go to the Excel sheet, Microsoft Excel sheet, where I have made the calculations easily.
This is the tabulation or a calculation made in Excel sheet. This moment distribution of frame number 5 with 3 columns in column layout for YouTube video. Considering all the columns and beams are continuous and fixed. Okay. Here we need these 1, 2, 3, 4, 5, 6, 7, 8, 9 datas. We need this. What are the 9 datas? The uniformly distributed load over the beam. Column length ground floor, column length upper floor, span 1 length in meter, span 2 length in meter, then beam depth, column width, column depth. These are the items required to calculate the bending moment in the column. This is the same sketch we saw previously. This is column, this is column, this is column. This one is beam. The joint A, joint B, joint C, I have given the names in this way. So this span and etc. we are feeding in this calculation. By feeding these items, what we are going to calculate as far as the joint B is concerned, we are going to calculate the moment of inertia of the section, beam moment of inertia. With some formula, we are going to calculate with the previously said data. From that, we are going to find stiffness factor of the section. From that, we are going to find the distribution factor. These items will be required in the moment distribution table. This is the actual table which is required for calculating the bending moment in the column. This is a simple table, but the calculations are done repeatedly 5 times or 4 times. One is, these are the spans, spans. These are the joint, A joint, B joint, C joint. This is A1 is a column, AA2 is another upper floor column. AB is the span or the beam span. BA is the same span but read in right to left. That is the hogging bending moment on the right hand side is found here. Likewise, everything is given here. So distribution factor as we calculated in the previous table, it is placed here. Then fixed end moment, it is based on WL square by 12. Then it is distributed like this, carried over. Some formulas, some methods are there. We are doing this. These are simple thing only. On totaling all the moments in the columns, the column A1 column, this total amount is 32.1217 is the bending moment in that left side column. In the bottom side, in the floor side, 38.29 is the bending moment in the column in the upper side, that is in the first floor. Likewise, the AB means this from left to right. The spans left side end hogging moment is 70.46. The same beam in BA side, the beam's moment in the right side is 83.33. Likewise, we can calculate all these things.
On working out the column bending moment through the moment distribution method, I have found that the column bending moment in this column is 31.8, in this column is this much, this column is this much. I have worked out this in this way. Okay, but working out the bending moment in the column with the use of moment distribution method based on very long calculation is not possible every time. This can be done in Excel sheet, it's okay. But before that, for completing this video, we shall find out one crude method or a empirical method to describe how much will be this column bending moment. These things I have found it out. Okay. These values are the maximum bending moment on the different beams. So I make a empirical relationship that 0.4 into this bending moment, 101 the beam bending moment into 0.4 is equal to 40.6 kilonewton, whereas this much is coming as 31.8. So we are going to adopt this as 40.40 kilonewton meter. As well, this much 73.61 into 0.4 is 29.44, whereas this is 27. This 29 is more than that, so we can design for 29.44 kilonewton meter. And this is also 143.56. This is 143.56 is the maximum bending moment in this beam into 0.4 is this is 57.4, whereas this is, and the worked out method is coming as 54. So this 57 is more than 54, and we can use this. In this way, I find this column moment may be approximately equal to 0.4 into beam moment is the column beam at the exterior column. Exterior column means the outer column in this way, and this way. These are the empirical method I have found it out. So this we will follow for the till the completion of this design process. Then we shall come and do this calculation of moment distribution method later. I have made that calculation of column bending moment from the maximum bending moment of the beam. That is by multiplying 0.4. I have written near to this column, every column near. The similar way we did in the previous drawing. For this drawing is 40.44. I have drawn this 40.44. We worked out as 29.44, 29.4. In this way I have worked out. See here, this is a beam resting on these two beams and it extends on cantilever. So for calculating those things, balance of the bending moment in the beam will be calculated for arriving this column bending moment. Means 32.64 minus 10.97. This is the balance bending moment. That is after neutralizing the Hogging bending moment on both sides. This is the balance bending moment which has been distributed into 0.4 is the column bending moment I am assuming. 8.67 kilonewton meter. This I am assuming. For this, see here I have written as 8.67. Similarly, I have made the calculation in all the drawings, all the columns. Now we are going to design. Design means arriving the size of the column, arriving the reinforcements, etc. That we shall see in the next video. Thank you. The persons who find it useful, please share it to other engineers, architect and students. Subscribe this video please. Thank you.